Hello. This is a video about radicals, the Pythagorean theorem, and solving quadratic equations by the square root property and by the quadratic formula. Let's get going. So radicals is another name for square roots, but first let's look at what a square is. So when I say a squared, of course that means a times a. If I had said a to the third power, it would be a times a times a, of course. Now, we say that 9 is the square of 3 because 3 times 3 is 9. Now, negative 5 squared is 25 because negative 5 times negative 5 would be positive 25. Now, when you square a number, it's always going to be positive, except for one exception. If you square 0, it's going to be 0. But every other time you square a number, it's going to be positive. So if the number is negative, you square it, it'll be positive. Or if you start with a positive number, you'll get a positive. Now, square root of a number means some number that when you square it gives you that number. So the square root of 7, for example, that means that if I have square root of 7 and I square it, that's going to give me 7. Because square root of 7 means some number that when you multiply by itself, in other words, square root of 7 times square root of 7, or square root of 7 squared, you will get the number inside, which is 7. If you have square root of 13 and you square it, you'll get 13. So always when you square a square root, you get that number that's inside the square root. So why does the square root of 64 equal 8? Well, that's because 8 squared, 8 times 8, is 64. All right, so what is square root of 55? So what this means is some number that when you square that number, you get 55. So it's some number that when you square it, gives 55. Now we know that 7 squared is 49, so that's not quite large enough. 8 squared is 64, so that's too large. So square root of 55 must be some number between 7 and 8. Now you could try 7.5. You square that, you get 56.25. So that's a little bit too large. So you try 7.4. 7.4 squared is 54.76. A little bit low. So we know it has to be between 7.4 and 7.5. And you could keep doing that process until you get what the square root of 55 is with any desired precision. Now, of course, we have calculators and tables that can help us calculate that. Now, we don't say, even though that negative 5 squared is 25, we don't say that the square root of 25 is negative 5. We say that square root of 25 is positive 5 because when the square root symbol really only means the positive square root. If we want to denote the negative square root, we just put a negative sign in front of it. Now there's no real number x, so that x squared is negative 4. Both 2 squared and negative 2 squared both equal positive 4, not negative 4. So that must mean that there's no negative number inside a square root. I'm sorry, if there is a negative number inside a square root, the answer is undefined. In other words, you can't do it. So the square root of negative 81 is undefined. All right? So anytime you see the square root of a negative number, it's undefined. Now, what do you do if you have something like the square root of x to the 6th power? Well, you can try to write it as something squared inside the square root. So we know that x to the 3rd times x to the 3rd is x to the 6th. So I could write that as x to the 3rd squared. And so the square root of that, well, the square root and the squaring just cancel each other out, so you just get x to the third. So what happened? We had x to the sixth, and we took the square root of it, and we got x to the third. So a note here, the square root function basically cuts the exponent in half. And you can see the formula there that takes 2c for the exponent and breaks it down to just c. In other words, it cuts the exponent in half. Now higher roots, well, x or a to the third power is the cube of a. Not the square, but the cube of a. And so the cube root of a number, let's say cube root of n, means some number question mark, let's call that thing question mark, so that that number cubed equals n. Thus, the cube root of a to the third power would be a. In other words, you see how that cube root and the cubing, they cancel each other out. All right? So here's an example. Cube root of negative 8x to the third. Well, you could write negative 8x to the third as negative 2x times negative 2x times negative 2x. And so we have negative 2x to the third power because there's 3 of them. Well, the cube root and the cubing cancel each other out. So you just get negative 2x. All right? So, by the way, cube roots can be, you can take the cube root of a negative number. Like, for example, the cube root of negative 8 is negative 2. Just looking at the numbers right now. So, now, what if you have the fourth root? Well, the fourth root of a number means that it's finding some number that when you multiply by itself 4 times gives you the number inside. Now, the fourth root of negative 16 is going to be undefined because there's no number that when you multiply by itself 4 times is going to be negative. It's always going to be a positive number. And you can see that if you try in various numbers. Now here's one that if you have the negative of the cube root of negative 27, well, you could write the negative 27 is negative 3 times negative 3 times negative 3, so you have 3 of them. So when you take the cube root of that, it just becomes one of them. So you basically have the negative on the outside and then times negative 3. And that ends up to be positive 3. All right. Now looking at this again, square root of 1/4. You could think of the 1/4 as 1/2 squared, because 1/2 times 1/2 would be 1/4. And the square root and the squaring cancel each other out, and you just get 1/2. So the square root of 1/4 is 1/2. All right, now that was all just discussing what square roots and cube roots and fourth roots are. But one of the main things that we want to look at radicals for is doing what we are going to look at right now. The product rule is a way to break up square roots. So for example, if you have a square root of 144, now you might know that the answer is 12 right off, but you can break up 144 into 9 times 16. So you have square root of 9 and square root of 16, and you can take the square root of 9, that just is 3, and the square root of 16 is just 4. So you get 12 in the end. Okay, so you can see how this works. Now in the next few examples, these don't come out to just a whole number for the answer. You get a radical involved in the answer. But if you have square root of 50, you could break it up. Well, first of all, it breaks up into 2 times 5 times 5. That's called the prime factorization of 50. And you know that 5 times 5 is 25. Now that's the reason why we wanted to say 25 here is because we can take the square root of 25. So you take the square root of 25 and you get just the number 5. Now the 2 is still 2, square root of 2, excuse me, because it's not the square root of 4, it's the square root of 2, so you can't take the square root of 2, you just leave it as that. But we could take the square root of 25 and get 5. So 5 radical 2. Now, if you have the cube root of 16, well, you need 3 of them. You need 3 2's. So you could break it up into 8 times 2, because 8 is 2 times 2 times 2. And the cube root of 8 will be just 2. And so you end up with 2 times the cube root of 2 for the answer. And here's another one. Cube root of 18. Well, 18 is 2 times 3 times 3. So you don't have a triplet. You don't have 3 of them. So you cannot simplify this. You just have to leave it as cube root of 18. Okay, you have to have, if it's cube roots, you have to have 3 of them. If it's square roots, you need 2 of them. If you have fourth roots, you need 4 of them to be able to simplify it. Now, the quotient rule says that if you have the square root of a quotient, you can break that up into separate square roots. The square root of the numerator over the square root of the denominator. So putting this to use, you have the square root of 49 over 4. You can break that up into separate square roots, square root of 49 over square root of 4, and that gives you 7 over 2. Here's another example. The first thing I did in this example is I reduced it. I know that 2 goes into 40 and 18. So I divided the top by 2 and I got 20, and the bottom 18 by 2 and I got 9. And then I took the square root of the top and the bottom. Now, the square root of the bottom, square root of 9, is just 3. So that simplified pretty easily. But the top, I know that 4 is a perfect square, so I can take the square root of 4. So I split this up into 4 times 5, so that I can take the square root of 4 and I'll get 2. And I also have x squared, and so the square root of x squared is just x. So I've got 2x and then square root of 5. So that's the numerator. Now, I probably won't have any of these on the quiz for next time. Maybe something as simple as the first example, but probably not the other ones. Now, this next example we can look at. You can go ahead and try this, and then I'll show you what the answer is. Okay, so what I did was I broke up the numerator and the denominator into separate radicals, but I first reduced. I know that 3 goes into 96, so I divided the top 96 by 3 and I got 32, and the bottom I divided by 3 and I got 7. I also canceled one of those x's, so that gives me x to the 6th on the top and no x's on the bottom. Now I can break up square root of 32, because square root of 32, or 32 is 16 times 2, so I can have square root of 16 times square root of 2, and also square root of x to the 6th. Now, I know what square root of 16 is. That's 4. And from what we looked at earlier, the square root of x to the 6th, when you have an even power like that, the square root of it, you can cut the exponent in half, so it'll be x to the 3rd. So I have 4 x to the 3rd, and then I have the square root of 2 at the end, and then over square root of 7. All right? So another example, rationalizing the denominator. Now, actually, this square root of 7 on the bottom is not the best thing to leave. So I'm going to show you how to handle that. So in this next example, I have 2 over square root of 20. I can split square root of 20 up into square root of 4 and square root of 5, because 2 times 2 is 4. I can take the square root of 4, and that gives me just 2. And so I end up with 2 over 2 times the square root of 5. Because I broke square root of 20 up into square root of 4, which is 2, and square root of 5. Now the 2's cancel, and so I end up with 1 over the square root of 5. And to get rid of the radical on the bottom, you can multiply top and bottom by that radical. So if I multiply top and bottom by the square root of 5, on the bottom I have square root of 5 times square root of 5. Now square root of 5 times square root of 5 is just plain 5. Remember, anytime you have the square root of something times itself, it's just going to be the number inside the radical. So we end up with square root of 5 on top over 5. Now I could have done that over here in this previous example. I could have multiplied the top and the bottom by the square root of 7. So I'm going to do that right now. And so we end up with 4x cubed times the square root of 14, because 2 times 7, both of them are inside the radical, so you can go ahead and multiply them back together, over just plain 7, because square root of 7 times square root of 7 is just plain 7. All right? But you can't cancel the 7 right here because one is inside the radical and one is not. The next example, you can go ahead and try that, and I'll come back in a minute. Okay, what I did in this problem is I broke up square root of 32 into square root of 16 times square root of 2, because 16 times 2 is 32. And because square root of 16, I can take the square root of 16. It's 4. So that's what I did. I got 28 over 3 times 4, because the square root of 16 became 4, times the square root of 2. Now the 4 cancels with the 4 inside of 28, so I have 7 over 3 times the square root of 2. Now do you recall, if I have the square root on the bottom, I can multiply top and bottom by the square root of that thing. So if I got a square root of 2, I'm going to multiply top and bottom by the square root of 2. And what is the square root of 2 times the square root of 2? Well, it's just 2. So on the bottom, I end up with 3 times 2. On the top, I have 7 times the square root of 2. And so the answer is 7 square root of 2 over 6. All right? So that's as simplified as I can get. Notice I don't have a radical on the bottom. All right? Now, in section 15.2, more simplifying radicals. It uses that same product rule as I mentioned. Here's another example, square root of 120. You can break that up into 4 times 30. Why? Because 4 is a perfect square. I can take the square root of 4. So I break up 120 into 4 times 30. I take the square root of 4, and that becomes just 2. And 30 doesn't have a pair in it. It's just 2 times 3 times 5. And there's no pair of numbers like 2 times 2, which is 4. So the answer is 2 times the square root of 30. In the last example, square root of 252. I can split 252 up into its prime factorization. 2 times 2 times 3 times 3 times 7. There's a pair of 2's and there's a pair of 3's. So I can write it as square root of 4, square root of 9, and then I also have this 7, so square root of 7. Now I can go ahead and take the square root of 4, that becomes 2, and I can take the square root of 9, that becomes 3. I don't need the radical anymore. Once I take the square root, I just write the plain number. So square root of 4 becomes 2, square root of 9 becomes 3, and then times the square root of 7. So 2 times 3 gives you 6, so you have 6 times the square root of 7 is the final answer. Now, why did we learn all this about radicals? Well, one reason is so we can apply it for solving quadratic equations that you see when you use the Pythagorean Theorem. Now, you should probably recall from past math classes the Pythagorean Theorem. The Pythagorean Theorem is I'm sorry, I'm looking for my tool for writing. This is the Pythagorean. This is the Pythagorean theorem. A squared plus b squared equals c squared. And it is used when you have a right triangle. So for any right triangle with legs A and B and the hypotenuse C, now the hypotenuse is the longest side. So in this first diagram, the hypotenuse is 12. All right, you got to have C being the hypotenuse. So we've got a squared plus b squared equals c squared. So the legs are 3 and b, and the hypotenuse is 12. So I'll call that c. So I'll go 3 squared plus b squared equals 12 squared, as you see in the work here. 3 squared plus b squared equals 12 squared. Now 3 squared is 9, 12 squared is 144. So I get 9 plus b squared equals 144. Now you can go ahead and subtract 9 from both sides, and you get b squared is 135. And then you basically take the square root of both sides. So we have b squared equals 135, and I basically am going to take the square root of both sides. So we get just b, because these two things cancel each other out, equals the square root of 135. You can actually simplify square root of 135 because 9 goes into 135. And so you can split it up into square root of 9 and square root of 15. Now the square root of 9 you can take, and that becomes 3. So it's 3 times the square root of 15. That is called the exact answer. If you get your calculator and go 3 times the square root of 15, you can get a approximate answer that's the decimal answer, 11.619. You should find the square root button on your calculator to be able to do that. Here's another example. A 70-foot tall pole needs a guy wire. If it is to be attached 30 feet from the base of the pole, how long must the wire be? So here's the pole. This is the pole, the 70, and you're attaching this guy wire right here, 30 feet away from the base of the pole. All right. So we want to know what the hypotenuse is. So this time it's the hypotenuse that's the unknown thing. So you just have your variable to be c, and 30 and 70 are your legs of the triangle. So 30 squared plus 70 squared equals c squared. 30 squared is 900. 70 squared is 4,900. You add that up, you get 5,800 equals c squared. Then you take the square root of both sides. And the square root of c squared would be just c. So c equals the square root of 5,800. Now, if you want the exact answer, you can split 5,800 up into 100 times 58. Why do I do that? Because you can take the square root of 100. 100 is a perfect square. It's 10 times 10. So the square root of 100 would be 10, and then you have 58. So 10 times the square root of 58 is the exact answer. The decimal answer, square root of 5,800, is 76.158. Now, of course, that's the best. I mean, that's the answer you would want if you're a construction person going to have to cut the wire you need. You're going to cut it maybe at 77 feet long, so you have enough. All right, now we have looked at how to solve quadratic equations using factoring. And so a quick review. A quick review of that. You can see here I've got some examples. If you had 5x squared minus 20 equals 0, you could factor this. You could first distribute out a 5. Always distribute out your greatest common factor first. And that gives you x squared minus 4. And then that's a difference of squares, right? X squared minus 4 is called a difference of squares. And so we could write it as x plus 2, x minus 2. So we've completely factored the left side of this equation. And then we break it up into our little equations. So we set the first thing that has an x, first thing that has an x in it, the x plus 2, set that equal to 0, and then x minus 2 equals 0. In the first case, we have x is negative 2. In the second case, we have x is positive 2. All right, another example is if you have 2x squared plus 5 equals 11x. First, we got to put it in standard form. You notice this is not in standard form like the last one. The last one had 0 on the right side and everything else on the left side. This does not. So we got to move that 11x over to the left. So we're going to subtract 11x from both sides. So we have 2x squared minus 11x plus 5 equals 0. And so the factoring of that is 2x minus 1 and x minus 5. Now, how did I know that? Well, I had to use the AC method, which we can, discuss that if you want some later time when we have class or not. But, I mean, we already went over how to do the AC method, but you could also use trial and error and just guess at what would go in these parentheses and keep checking until you get that right. You check it by foiling it. So anyway, you get 2x minus 1 equals, or times x minus 5 equals 0. Then you set each binomial equal to 0. So 2x minus 1 equals 0. You move the 1 over, you get 2x equals 1. Divide by 2, you get 1/2. X is 1/2. Here, x minus 5 equals 0. You move the 5 over, you get x is positive 5. So we have just solved a couple equations by factoring. So factoring, of course, is not the only way to solve a quadratic equation. There are some other ways. And one way is called using the square root property. What is the square root property? Well, it basically says that if you have x squared equals a number, a is some number. If you have x squared equals a number, where a is greater than 0 or equal to 0, then x would be plus or minus the square root of a. So in the first example, this is the most simple example I could think of. If x squared equals 7, using that property, then x would be plus or minus the square root of 7. Okay? Simple for this, simple type. Now, notice that x squared, using the property, x squared has to be alone. So you have to make sure that x squared is all by itself and you've moved everything else. Now, that's what you have to do first in this next example. I don't have x squared alone. I've got that 9 in front of it. So the first thing I do is divide both sides by 9. So I get x squared equals 5 over 9. Now I have x squared alone. And so x would equal plus or minus the square root of 5 over 9. Now you can take the square root of the top and the bottom separately, and you get square root of 5 over the square root of 9. Of course, square root of 9 is just 3. So plus or minus the square root of 5 over 3 are your two answers. Positive square root of 5 over 3 and negative square root of 5 over 3. All right. In the next example, I actually have something squared already isolated. I've got x minus 3 squared. So I don't want to try to move the 3 yet. I'm just all ready to just take the square root of both sides. I've got it in the form of something squared equals a number. So I would basically take the square root of the left side and get x minus 3 and do plus or minus the square root of 17 on the right side. So notice I just remove the squaring because square root and squaring cancel each other out. And you get plus or minus the square root of 17. Now I need to move that 3 over. I've got x minus 3. So I need to add 3 to both sides. So when it moves over to the right side, it becomes positive 3 plus or minus the square root of 17. Or 3 plus the square root of 17, which if you want it as a decimal, it's 7.123. And 3 minus the square root of 17, which is negative 1.123. All right? So that's how to solve using the square root property. Let's look at just a couple more examples and summarize this, and then you can try it for your homework. So, this is the same example as I have just gone over. So let's look at the next example. So if you have 2x minus 7 squared, notice that's in parentheses squared, plus 5 equals 9. So I want to isolate the squared term. So I want to isolate this 2x minus 7 squared. So I would subtract 5 from both sides. So if I subtract 5 on the left side, it just disappears. If I subtract 5 on the right side, I get 4. So my first thing I do is I get 2x minus 7 squared equals 4. Now, you're ready to take the square root of both sides because you have something squared on the left side. So then you take the square root of the left side and the square root of the right side. So you end up with 2x minus 7 equals plus or minus 2 because the square root of 4 is just 2. All right, then you want to add the 7 to both sides. So I add 7 here and add 7 here. So I get 2x equals 7 plus or minus 2. Now, that's two things on the right side. It's 7 plus 2 and it's 7 minus 2. So let's split them up into separate things. So 7 plus 2 is 9. So I've got basically 2x equals 9. And 7 minus 2 is 5. So I've got 2x minus or equals 5. So if I divide both sides by 2, I get 9 over 2 and 5 over 2. So those are my two answers to this problem. So after I take the square root of both sides, then I basically solve each equation that I get. So you try this one. I'll pause the video and try this one, and I'll show you the answer in a minute. Okay, so the first thing you want to do is move the negative 8 over to the right side. So we're going to add 8 to both sides. So you get parentheses 5x plus 3 squared equals 12. Now you have your parentheses squared isolated. You've got your squared thing isolated. So now you can take the square root of both sides. And so it basically just gives you 5x plus 3 on the left side because it removes the squaring. Remember, square root and squaring just remove each other. And then on the right side, you put the plus or minus square root of 12. Now I want to move this 3 over first, so I'm going to subtract 3 from both sides. And just ignore this plus sign. I didn't mean to write that. But subtract 3 from both sides. So you have just 5x on the left side equals negative 3 plus or minus. Now I went ahead and started breaking up square root of 12. I can split square root of 12 up into square root of 4 and square root of 3 because 4 times 3 is 12. But I can take the square root of 4, and that gives me just 2. So 2 square root of 3. 2 times the square root of 3. So I have negative 3 plus or minus 2 times the square root of 3. And then all I did here is just divide both sides by 5. And so that 5 got moved down to the bottom because we're going to divide it by 5. It'll cancel on the left side and it'll end up on the bottom on the right side. So that's the answer. Negative 3 plus or minus 2 times the square root of 3 over 5. Okay, so the last thing we need to look at in this section is the quadratic formula. How do you solve equations using the quadratic formula? Well, there's 3 steps. The first 2 are very easy to do. The third one is a little bit more involved, that's for sure. But the first 2 you should be able to do without much trouble. All right. So when a quadratic equation is in the form ax squared plus bx plus c equals 0, that's called standard form. It can be solved by the quadratic formula. And the derivation of the formula, you don't have to know the derivation of the formula, but if you're curious, you could look on pages 182 and 183 of the textbook. All right, so here's the formula at the top in the box. What you are going to do is figure out what A, B, and C are. Step 1, identify the A, B, and C. Step 2, you're going to plug the A, B, and C into that formula. Now, you're not going to plug any x's into that formula, just the numbers for A, B, and C. All right, so let me give you an example. This equation right here, 2x squared plus 7x minus 5 equals 0, is in standard form. You got to make sure that it's in standard form. So I've got it in standard form, and so whatever the first coefficient is A. So A would be 2. It's the number in front of x squared. Then B is the number in front of the x. So that would be 7. And then C is the next number that's just the plain number with no x's in it, in this case, -5. So A would be 2, B is 7, and C is -5. So that's the first thing I do, is make sure it's in standard form, which is this form here, ax squared plus bx plus c equals 0. And then I read what A, B, and C are. That everybody should be able to do that. Step 2, we're going to plug those into the quadratic formula. Now the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to put that in. So I've got -b. So b is 7, so it'd be -7 plus or minus the square root of 7 squared minus 4 times a, but a is 2, so 4 times 2 times c, which is -5. So I put everything in the top, and then I just go 2 times a, or 2 times 2 on the bottom. Of course, 2 times 2 is 4, so the bottom is 4. That's easy. On the top, you've got to do 7 squared first. You always do exponents first. So 7 squared is 49. And then you can start multiplying these numbers together. You want to do all the multiplications before you do that subtraction. So 4 times 2 is 8. And then I have 8 times negative, I got actually -8 times -5. So notice how you got two negatives. You got -8 times -5, or -8 times -5, but minus a negative is still going to be negative. I'm sorry, it's still going to be positive. So you end up with positive 40 there. So you end up with -7 plus or minus the square root of 49 plus 40. Now you can just go ahead and add that. That's 89. So -7 plus or minus the square root of 89 over 4. Now that's two answers. That's -7 plus the square root of 89 over 4, and -7 minus the square root of 89 over 4. So those are your two answers to the quadratic equation, or quadratic form, using the quadratic formula. Let's look at another example. Okay, I've got 4x squared minus 3. Now clearly this is not in standard form. You do not have 0 on the right side. So first thing you want to do is move the 3 over. And also, if you're ever missing a term, I'm missing the x to the first power term. I'm missing the plain x term. So I want to write 0x there. And so A would be 4, B would be 0, and C would be -3. So that's step 1. Step 2, I plug them into the formula. So B is 0, so -0 plus or minus the square root of 0 squared minus 4 times A, which is 4, times C, which is -3. And so over 2 times 4. And then 0 minus 16 times minus 3. Now, I would do this multiplication, always do multiplication first. So negative 16 times negative 3 is positive 48. And then you have 0 plus 48. So just basically 48 inside the square root. So you have 0 plus or minus square root of 48, or in other words, just plus or minus square root of 48 over 8. Now I can break up 48. 48 is 16 times 3. And square root of 16 you can find as a whole number is 4. All right, so square root of 16 becomes just 4. So we basically end up with plus or minus 4 times the square root of 3 over 8. And then you can cancel the 4's. 4 goes into 8 2 times, so you end up with plus or minus square root of 3 over 2. Now let me show you something. Okay, the trick I wanted to show you was this particular equation actually is just about as easy to solve using the square root property. If you isolate x squared by dividing both sides by 4, you get x squared equals 3 over 4. And then you take the square root of both sides, you get x is plus or minus the square root of 3/4. And then split it up top and bottom, and you get plus or minus the square root of 3 over the square root of 4. But the square root of 4 is 2. So you basically get plus or minus the square root of 3 over 2. And that's the same answer that we got using the quadratic formula. So, sometimes the square root property is just as easy or even easier. Okay, some more examples. You see here that I have an equation with a fraction in it. You can get rid of fractions pretty easily just by multiplying through by the number that's in the denominator, the number on the bottom of the fraction. I'll show you. All right, so if you have this quadratic equation here, you could first move the 2 over, so I get it in standard form, 1/2 x squared minus x minus 2. But I could multiply everything by 2 because 2 is on the bottom. If I multiply 2 times 1/2, that I just get 1 because the 2's cancel. So I get basically 1x squared, and then I multiply everything else by 2, minus 2x minus 4 equals 0. Of course, 0 times 2 is still 0. So if you ever have a fraction in the equation, you could multiply everything through by the denominator and it gets rid of the fraction. But you got to make sure you multiply everything by that number. All right, so now I've got it in the form, and a would be 1. The number in front is 1. B would be negative 2, and C would be negative 4. All right, now notice that B is negative 2. So when we do negative of b, we're going to have negative of negative 2. So negative of negative 2, that's going to just change to just positive 2. But let's keep going. And then b is negative 2, so negative 2 squared minus 4 times a, which is 1, times c, which is negative 4. And then, so I've got this negative negative 2, that becomes just 2, plus or minus the square root of negative 2 squared is 4, minus 4 times 1, which is minus 4, times negative 4. So you end up with basically 4 plus 4 times 4, or 16. And so you get 2 plus the square root of 20 over 2 on the bottom. Now, there's a couple different ways to proceed from here. I would recommend that you split it up into separate fractions at this point. Split it up and say 2 over 2 and square root of 20 over 2. Now the 2 over 2 just becomes 1. And so you have 1 plus or minus the square root of 20 over 2. Now you can actually break up square root of 20 into square root of 4 times square root of 5. And the square root of 4 becomes just 2. And so you end up with 2 radical 5 over 2. And the 2's cancel. And so you have 1 plus or minus the square root of 5. So that's the final answer after all the simplifying. Now, if you got to as far as like right here, 2 plus or minus the square root of 20 over 2, I would give you most credit. I would give you 3/4 of the credit because you've gotten 3/4 of the way along. That's why showing me your work and collecting the work and seeing your work is valuable, because you could make one little mistake in this whole process and get the answer wrong, and it's not fair to take off all credit for it. So I want to see your work. All right. So you can look at this carefully. Look at the book's examples. The book has a bunch of examples as well. If you look at the text in this section. All right. Now, the next thing is this equation here, 20x squared equals 3 minus 11x. I need to move everything over to the left side and have 0 on the right side. So the first thing I do is I add 11x to both sides. It moves it over. So I got 20x squared plus 11x. And I subtract 3. So you get minus 3 equals 0. So now A is 20, B is 11, and C is negative 3. So I'm going to plug these into the quadratic formula. So I do negative b, so negative 11, plus or minus the square root of 11 squared minus 4 times 20 times negative 3. And so you have negative 11 plus or minus 121 minus 80 times negative 3. Now 80 times negative 3, well, negative 80 times negative 3 is positive 240. So you end up with square root of 361 in the numerator. On the bottom, you have 2 times 20 or 40. So you end up with this. Now, square root of 361, that actually is a whole number, because you can take the square root of 361. It's 19. Now, sometimes you got to play with it on the calculator and just see, if it's a perfect square. So square root of 361 becomes just 19. So you have negative 11 plus or minus 19 over 40. Now you do the two solutions. You go negative 11 plus 19 over 40, and that gives you 8 over 40, or 1 over 5. And negative 11 minus 19 over 40, which is negative 30 over 40, or negative 3/4. So the solutions are 1/5 and negative 3/4. So this time we didn't end up with radicals. We ended up with rational numbers, they're called. So that's, the answer to this one. It's all the way simplified. Okay, so try these or at least the first example, and then I'll show you what the answer is. All right, so what you could do in this one is first move the 8x and the negative 2 over to the left side. So you'd have negative 8x plus 2 equals 0. And so A is 3, B is negative 8, and C is 2. So that's what you want to do. Get everything over on one side, and then read what A, B, and C are. Now plug those values into the quadratic formula. So I have negative b, but b is already negative, so it's negative of a negative. So you're going to have negative negative 8 plus or minus the square root of negative 8 squared minus 4 times a, which is 3, times c, which is 2, all over 2 times 3, 2 times a, which is 3. And then on the last line, you see that negative of negative 8 becomes just 8. So I have 8 plus or minus square root of 64 minus 24. I went ahead and multiplied 4 times 3 times 2, and I got 64 minus 24 over 2 times 3, which is 6. And so that's 8 plus or minus the square root of 40 over 6. Now, like I said, if you could get this far, I would give you most of the credit. I would maybe just take off one single point or so for not simplifying it completely. So to simplify it completely, you could split square root of 40 up into square root of 4 times square root of 10, and the square root of 4 becomes just 2. So it's 8 over 6 and 2 square root of 10 over 6. And you could reduce. 8 over 6 reduces to 4 over 3. And the 2 cancels on the 2 radical 10 over 6. And you get square root of 10 over 3. And then you can bring them back together because they both have the same denominator and say 4 plus or minus the square root of 10 over 3. All right? So that's the fully simplified answer, exact answer. But at any stage here, you could have got a decimal answer like 8 plus or minus the square root of 40 over 6. You could do on your calculator 8 plus the square root of 40 over 6 and got one answer, and then 8 minus the square root of 40 divide by 6 and you get the other one. Okay, pause it if you haven't already done it, but work on this last one, and then you can look at my answer. All right, so what I did was I moved the 3x to the left side, so I've got 5x squared minus 3x minus 1 equals 0. A would be 5, B would be -3, C would be -1. And then I plug these numbers into the quadratic formula, which starts with negative b, so I'm going to have negative of -3 plus or minus the square root of -3 squared minus 4 times a, which is 5, times c, which is -1, all over 2 times a, so 2 times 5. Now, -3 becomes just 3. This becomes 9. And I've got -20 times -1, which would be +20. So in the parentheses, I've got 9 plus 20, which becomes 29. On the bottom, you have 2 times 5, which is 10. So it's basically 3 plus or minus the square root of 29 over 10. Now, you can't simplify the square root of 29. Just, it's a prime number. 29 is a prime number, so you can't even, try to simplify it or break it up. I just have some more examples of all the types of solving that we have. The first example, 5x squared minus 7x equals 0. Actually, this is more easily done just by factoring. So you could distribute out x, and you get 5x minus 7. And then you could set that equal to 0 and 5x minus 7 equal to 0 because you have the product of two things equals 0. So either the first thing is 0 or the second thing is 0. And so you get x is 0 as one solution, and you move the 7 over, you divide by 5, you get 7 divided by 5, which is 1.2. Actually, it's 1.4. My mistake. That should be 1.4 there. Anyway, so your solutions are 0 and 1.4. All right. Now, in this next example, you have 2x squared plus 1 equals 3. So the first thing you want to do is move that 3 to the left side. So you get 2x squared minus 3x plus 1. Now, you could use the quadratic formula for this, or you could use factoring. Now, I show the AC method here. You can, follow that through there and look at it. I ended up getting it factored right here, x minus 1 times 2x minus 1. And then I broke it up into my little equations, and I got x is 1 or x is 1/2. Or you could have used the quadratic formula, with a being 2, b being -3, and c being 1. Plug them into the quadratic formula. You should end up with the same answers. In the next example, example 3, because you have this parentheses squared, I would suggest the square root method by the square root property. So move the 7 over, subtract 7, so you get x minus a half squared equals 4. Then you could take the square root of both sides and get x minus a half equals plus or minus square root of 4, which is just 2, so plus or minus 2. And then you could add a half to both sides to get rid of that half that's on the left side. And so that gives you x equals a half plus or minus 2. Notice the plus or minus is with the 2. So it'd be 1/2 plus or minus 2. And so your solutions are 1/2 plus 2, which is 2.5, or 1/2 minus 2, which is negative 1.5. And so that was done most easily with the square root property. All right, example 4 on this page. Here's the equation. You can move the 5x over to the left side, and you get 6x squared minus 5x minus 1. You could try to do this by factoring, but I showed here by the quadratic formula. So A is 6, B is negative 5, and C is negative 1. And then you just plug those into the formula. So it's negative B, so negative of negative 5, so negative 5, plus or minus the square root of negative 5 squared, minus 4 times A, which is 6, times C, which is negative 1. And then negative 5 squared gives you 25. And of course, negative 5 is just 5. Minus 24 times negative 1. Well, negative 24 times negative 1 is positive 24. And on the bottom, you have 2 times 6. So that adds up to 49 inside the square root. So you have 5 plus or minus the square root of 49 over 12. Now, you know that the square root of 49 is 7. So 5 plus or minus 7 over 12. Now 5 plus 7 is 12. So 12 over 12, which gives you 1. Or 5 minus 7, that's negative 2 over 12. But negative 2 over 12 reduces to negative 1 over 6. So your two solutions are 1 and negative 1/6. And both of those numbers, if you try them in the original equation, should work. Now, it's a little bit difficult to plug in a fraction like negative 1/6 in there, but you could. All right? So hopefully this makes some sense to you. Just try it in the homework. If you have any questions, let me know.